In this part of Let's Build a Chatbot in C# using Microsoft Agent Framework, we're going to look at a Blazor server baseline. Baseline meaning that we have an ambition to build multiple frontends and multiple backends, but in order to get going, in order to learn the basics, a Blazor server project is really a good way to learn, because we don't need to deal with multiple processes and so on. And it's a perfect tool as well for internal chatbots. For more public-facing chatbots, we might want to use a different front end and have a dedicated backend. But let's use it to get going. So what we have in our repo, which we introduced in the latest part, is a Blazor server. And it's a standard Blazor server. The only really thing I have changed in that server is that in app.razor I put in that I don't want pre-rendering on, because it's just annoying if you want to use the Blazor server as is. Beyond that, I have more or less put all the code we need in terms of Blazor in this chatbot page, which we're going to explore in a bit. But else we have a little service for conversations, which will be a dedicated video about. We have a few models about the conversations, which that video will also cover. And then we have our components. Inside here, we are using the Aspire. So we are getting our dependency injection from Aspire primarily. So we get our AI factory from the Agent Framework toolkit, and we're getting a little bit of setup from a Weather Maps service, so we don't just make dummy tools, but actually make a real tool that goes out live and grabs data from a weather service. Let's run it, and then we'll jump into the code after the fact. So when we start, because it's Aspire, it of course starts up in our resources. And as of this recording, we only have the Blazor server, but you might run this at a point where there's multiple different resources for various frontends and backends. But if you want to run this, it's in the Blazor server only. In order to run it, we need the parameters. So you need to put in an Azure OpenAI endpoint, an OpenAI API, and an Open Weather Map service key in order if you want to run it yourself. So running it looks like this. We have a classic chatbot interface with some conversations and new chats over here. We haven't made any chats yet. Over here there's some nerdy stuff with options. Right now we only have streaming, but there might come more options as we go along. And streaming in general will be its own video as well, because it requires a little more. But what we can do is, of course, we can talk to the AI, ask it hi, get an answer back, and the answer is here, but we also get what thoughts it had and what tokens it used. And there's also tool calling involved, so we can say, what is the weather like in Paris? Send that along. It will now do tool calling. Let's try that again. OpenAI have been a bit troublesome at of this recording, so we're gonna see again if we get along. There we go. We saw thoughts, tool calling along the way. So it put in Paris, France, got some data back from that tool, thought a bit more about that output, and gave us the final answer. And everything is stored over here, so we can switch, go back, and see everything as this is stored. So right now this is stored down in file, with a JSON for each one of these conversations. We can see that conversation here, but we'll go more into this in details in the conversation video. We can also do streaming. So we can say how to make soup and get a streaming answer back to us. So both thoughts streaming and the real answer streaming back. So this is what we have. Let's explore various things in overview, and then there are several videos about some of the aspects in details. So let's have a look at what we have. So the only thing I put in program CS is these 3 lines of code. We are taking our conversation service, which is just normal C# code. We are doing the service defaults in order to get our agent framework dependency injection and our local storage. So in here, we are just grabbing our keys like we have seen in previous videos about agent framework. And I'm using my agent framework toolkit NuGet package, which takes care of being able to build AI agents. So it's just an initialization of the agent that is a bit different and easier, but using the agent is completely normal as normal agent framework. As I mentioned, I also use OpenWeather map, and if you need to grab something from them, you need to go to OpenWeather map, and you can just sign up for free and get an API key. So there's no cost at all in order to run this. So the system here will ask you for this, and you just put in the keys and you are ready to go there. This one we'll cover later, and the local storage is just so we can use the browser's local storage in order to save our data in local storage, like settings, so I don't need to turn on streaming every single time I try it out, for example. For local storage, we have a key for that, and there will probably come more keys in here. The conversation service, as mentioned, will cover in another session, and same goes for the conversations, but a conversation is more or less just a set of messages and some more stats about it. I will also, in that video, go into why I'm not using agent sessions from Agent Framework. We have an extension folder, just to take some of the AI content, which we will talk about in the tool calling video, but just some handy extension methods in order to work with these a little more easy. But the main part, of course, is our chatbot. So if we look at the chatbot, we have a small design. We have a chat page with a left sidebar, which is out in a component by itself. And that will be covered in the conversation video. And we have the right sidebar, which is just setting up if we have streaming or not using local service. So this one we don't really need to cover. Whenever we have messages back from a conversation, we will show them in a list here. So we will show the user parts, which is the right-hand side of a chat bubble message system. And we're going to use the assistant part, where we're just going to show the text and the usage tokens out. So just a normal message with the text out directly from Agent Framework. But in the other videos, we will look at how we put out reasoning, not the visuals as much, but how we actually get them and why this is more difficult. And down here, I have something called mid-turn visuals, which is the streaming process mostly, but also the little ... when we're waiting for a non-streaming. So this is just the visuals, but of course in the video about streaming, we are gonna look more in details into that. Then we have the form at the bottom, the input form, where we just use normal Blazor. The only thing we do is we use some JavaScript here on key down, because we can't really use the Blazor version of it, because if we did, we would end up sending between server and browser constantly, and if you type really fast, it would not be able to keep up. So the key down here is to be able to press enter in the field, so we don't need to use the mouse to press the send button, and still be able to use the shift key in order to make multi-line sendings. So that is the only GUI we have. Each of these GUI elements we will cover in more details a little later on. If we look at the backend part, it's also fairly simple. We are taking dependency on our agent factory in order to make AI agents. We're taking dependency on the service for the conversations, and the local service, and the Weber map. Behind the scenes, we have an input field in order to put in the input, and we have a conversation, which is just an empty conversation at the beginning. Then we keep track of if we're streaming, and if we're streaming, what is the streamed response so far, the text gone back, and the streamed reasoning back. And then we have something called stream content, which is where the tool calls live. So we'll cover that in the tool call. Then we have the left sidebar, just so we can grab what whenever we set a new conversation to react to that. On initialize, we'll just check if we have set streaming in our local storage, so nothing big there. But of course, the big one is the send async, meaning we send a new message. So we just grab our input, trim it, and if no input was found, we will of course not do anything. We will reset a bunch of these values, so whenever we send in something new, it shouldn't show the old streaming and stuff like that. Then we are building our agents. In our case, we can just call it an AI agent, so it's more easy to understand from the system. But we have our agent from Agent Framework, Azure OpenAI in this case, and I'm just building an agent using Responses API. I'm using Responses API in order to get the thoughts back. In normal chat client, we are not allowed to use normal chat client because it can't give us what the reasoning summary was. I'm using ChatGPT 5 Mini, but you can do whatever. And in this case, I'm using medium reasoning effort. I'm getting all the details of the summary back. And as a tool, I'm using the weather tools, which comes from Agent Framework Toolkit as well, which is just a weather for city. So behind the scenes, it will call Open Weather Map. I have a separate video about these weather tools in general, if need be. But suffice to say, it's a tool that takes an input of a city and puts an output in JSON format on what the weather is like in that city. So that's our main agent. We also do a little agent because whenever we do the conversations, let's have a look here. When we start it up again, we want in our conversation sidebar to have a title for our conversation. And whenever we did this, how to make soup, it actually used a small agent to take that question and make a title for that. And that's what we're doing here. So if we are missing a title, meaning there is no title yet in the conversation because it's a new conversation. We just make a small title generation agent. In this case, I'm using a 4.1 Nano, the smallest model I have available right now, and just saying, giving the following message, generate a max 25-char long title for this question. So we're just doing that using structured output here, and we're just using that response in order to get our title. And then we add the conversation, so when a new conversation actually has something, we show it up in the left sidebar. We then put the new message into our conversation, so it has the full back and forward, and we are updating the GUI in order to see that new conversation, so we can look at our question before the answer comes back. Then there's two ways of doing this, either streaming or non-streaming. Non-streaming is very, very simple in that we just get our chat messages from our previous conversation, send them along so it has the full context, and once we get the results back, we just put it back into the conversation, meaning we take all the messages from our response and put in the usage on the last message. If it's streaming, it's more complicated, which I will leave to the streaming video. But essentially, we are using the streaming in Agent Framework, but need to do a bunch of extra stuff in order for it to really work. Once we're done with either streaming or non-streaming, we do an invoke, so our user interface will update, and then we're storing the conversation down into some files. So nothing really more is happening here. Whenever we press the new chat, we of course just make a new conversation. When we want to switch to an existing conversation, we just do that from the left sidebar and set that as the active conversation. If the streaming is set over on the right side, we set that value and save it in local storage. And once we start new things, we of course need to reset various values. So that is everything. Again, I want to go into the reasoning, the tool calling, and the conversation on why I've done it the way I've done it in 3 separate small videos after this. But now you have the baseline of what we are about to build, in this case in Blazor Server, but later on we'll see how this evolves into multiple backends and multiple frontends. So see you in the next one.